So let's continuing with z-test, and let's do an example when we're not given any sample data. Jeffrey, as an 8-year-old, established a mean time of 16 seconds for swimming the 25-yard freestyle with a standard deviation of 0.8 seconds. His dad, Frank, thought Jeffrey could swim the 25-yard freestyle faster using goggles and his time would decrease. Frank brought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 25-yard freestyle swims. For the 15 swims, Jeffrey's mean time was 15.8 seconds with a standard deviation of 1 second. Did the goggles decrease his time? Use a level of significance of 0.05. Assume the swim times for the 25-yard freestyle were normal. All right, so let's talk about what we have. So I know I have a population mean, which is 16. I know I have a population standard deviation, which is 8. And you might be like, how do you know that? And I know that because I'm given a sample. If I go later in the problem, I'm given a sample. And they told me that the sample had 15 swims, which is my sample size, a sample mean of 15.8, and a sample standard deviation of 1. Sometimes the easiest thing to do is go find out what your sample is, and then the remaining values could possibly be your population. So again, my sample size is 15, my sample mean is 15.8, and my sample standard deviation is 1.0. So my population mean up here is 16 because it was a time that had been established with a population standard deviation of 0.8. Even though it doesn't say population standard deviation or known standard deviation, I know because it said that it had been established. Something, if it says it's established or we know this or population, you can assume it's the population standard deviation. So conduct a hypothesis test using a 0.05 level of significance. And the reason I know it's level of significance is because of the little alpha. And the last piece of information I need is the decrease. So they thought his time went down based on using the goggles. So I know this is a z-test because of the population standard deviation being given. So my null and alternative hypothesis. Again, my population mean was 16, and his dad thought that time had decreased by wearing the goggles. If you go look on the chart, the less than symbol is the same when we use below, beneath, or decrease. And it's in the alternative hypothesis. So the population mean is less than 16. So the mathematical opposite, which is greater than or equal to, is in the null. And you can see I have that here. So again, my null is the mean is greater than or equal to 16. My alternative is that my mean is less than 16. Is this a right-tailed, left-tailed, or two-tailed test? It's left-tailed because it's less than or below. I always think of less than symbol, left-tailed. Is the population standard deviation known? And if so, what is it? The population standard deviation is 0.8. And we talked about that before because that was given in the problem and it was an established thing. So I'm going to go to Minitab and I'm going to show you how to put it in. So I'm going to go to my screen, close all my stuff, and then I'm going to go to Minitab. I'm going to open it up. So then I'm going to go to Stats, Basic Statistics, 1 Sample Z. I don't have a sample for this one, so I hit Summarize Data. My sample size was 15 because he had 15 sets of swims. Sample mean was 15.8. Again, I just got that from the problem. The known standard deviation. This is not your sample standard deviation. This is the population standard deviation. Be careful of that because that could make you miss the problem. I'm going to click Perform Hypothesis Test, and I'm going to put my hypothesized mean as 16. The hypothesized mean is the one that we use when we are making the hypotheses. So hypothesized mean, that number is what you use there. Click Options, And remember, my level of significance was 0.05, and that's okay because my confidence is 95%. So those basically have that relationship where they are being used the same way. This is going to be changed to less than. And again, it's less than because in my alternative, I'm using the less than symbol. And it says right here, alternative hypothesis. Because it wants the alternative hypothesis, I have to put the sign of the alternative hypothesis in that. So I hit OK, and I hit OK. And I'm given all the information. Again, I'm given the sample size, sample mean, and here I'm shown the alternative hypothesis. Again, be careful because the null is slightly different than what we're using in the class. So here I go, the z-value and the p-value. So the z-value for this one is negative 0.97 and the p-value is 0.166. So let's go back to our slideshow. All right, so again, and I also have in the PowerPoint how to put stuff in. And if you can see here, I have the same values for the Minitab instructions. And if you want to here, I walk you step by step how to do it. So I've got my Minitab stuff. So let's keep going with what I have. So I was given the sample mean in the problem, the sample size. And again, I know it's a z-test because the population standard deviation was known. So what's your z-test statistic and p-value? So my z-test statistic is negative 0.97 and my p-value is 0.166. So I want to look at my p-value versus my level of significance. 0.166 is greater than 0.05. And because it's greater, I fail to reject my null, which means I'm going to keep my null. My null is the one that is true. And the reason for that is because my p-value was larger than my level of significance. So what does that mean? So let's go back to our hypothesis. Let me go back out here. And I'm going to do this for just a second. Where is it? So here. So I failed to reject my null. Oops, sorry, wrong one. Oops, let me get back to it. Oops, I went too far, but here we go. Okay, so I failed to reject my null. All right, so this, remember, this was my original claim. And when I failed to reject my null, I found that this one was true. And so this was false. And I want to conclude based on my original claim. So my original claim was false. So when I go look at it, did the goggles decrease his time? No, the goggles did not decrease his time because I found that to be false with looking at the P and the level of significance. So again, because my P was greater than my level of significance, I failed to reject the null, which means the null was true and the alternative was false. Because the alternative was my original claim, I have to conclude that. So at the 5% level of significance, we can conclude that Jeffrey does not swim faster with his new goggles, or we could say there is not sufficient evidence to show that Jeffrey's mean time to swim the 25-yard freestyle is less than 16 seconds. So what did that show? The goggles really didn't do anything to help his time. There was no decrease in his time. So that's how we conclude these tests.